Hey everybody, thanks for tuning in today. Here we're going to talk about another rule for taking derivatives called the product rule. All right, you may remember from your algebra or before classes, product is what you get when two numbers are multiplying. So we use the product rule when we have two functions that are multiplying. So let's read along here. Although the derivative of the sum and difference of two functions is simply the sum or difference of their derivatives, the product and quotient of two functions are handled quite differently when differentiating. So let's take a look at the product rule. Here we have a function f times g. In order to take the derivative of f times g, there's two ways to do it, but basically the same thing. You can see all I'm doing is switching these two when you go over here. All right. So I usually use this method. It's the first function, f, times the derivative of the second function, plus the second function, g, times the derivative of the first function. Okay, because 2 plus 3 equals 3 plus 2, you can switch those around as well and get the same answer. So let's take a look at how one of these is done. It says find the derivative of h. And you can see we have two functions that are multiplying each other, right? Here's the first function. And here's the second function. So to take the derivative of h, we're going to do h prime equals the first function times the derivative of the second function, which is just 4, plus the second function times the derivative of the first function, which is 3 minus 4x, using our power rule that we learned last time. And that's it. That's your derivative. There's really no need to simplify this unless you want to, or in case this was a multiple choice question. So if we did simplify this, we would get the following. And then combining like terms, we would get negative 24x squared plus 4x plus 15. Hopefully I didn't make any mistakes there. But really, like I said, you could stop here if this is a written question, and we're okay with that. All right, a grader would give you full credit for that because we're trying to test your calculus skills, not your algebra skills here. The next step and the next step are mostly just simplifying in algebra. All right, and below that, simple question here. Do we have to use the product rule for that problem? Sometimes you have to use the product rule. There's no way around it. But in a problem such as this, we do not have to find the product rule. What we could have done is rewritten h by multiplying this out. So we get 15x plus 12x squared minus 10x squared minus 8x cubed. Okay, and if we rewrote that in descending order, negative 8x cubed plus 2x squared plus 15x. And if we took the derivative of that using our power rule, negative 24x to the second plus 4x plus 15. And you can see the derivatives are exactly the same. Two different ways to do it, but both work the same way. So here's a couple of practice problems. At any point as you're watching this video, if you feel comfortable and you want to try one on your own, go ahead and pause the video and then come back when you're ready. Let's take a look at A. We have x times sine of x. So our derivative is going to be the first function times the derivative of the second function plus the second function times the derivative of the first function. Okay, and since we don't need to really write that 1, our final answer could be just like that. Part B, we have e to the x times x. So our derivative, first function times derivative of the second function, plus second function times derivative of the first function. So that's it. We can simplify it by getting rid of that 1. And sometimes, if this is a multiple choice type question, you might see it in factored form by factoring out an e to the x. Okay, all three of these are the same answer. All three of them are accepted answers as well. All three of them represent the derivative of g. Third one. Okay, we see we have a product of 2x and cosine x. In the second term, there's no product here. Okay, you might think, well, it's 2 times sin of x. Yeah, it is 2 times sin of x, but we don't need to do, remember the 2, we can just use the scalar multiple rule. We don't need to use a product rule on that. So derivative of h would be h prime, and we have first function 2x times derivative of the second function, negative sine x, plus second function cosine x times derivative of the first function, which is 2. And that is just a derivative of the first term. And then the second term, the derivative of negative 2 sine x would be negative 2 cosine x. All right, so now we can do some simplifying if we want to. Again, it's not necessary unless this is a multiple choice question. And we could factor out a negative 2 if we wanted to. But this is good enough. And in fact, the line above that would have been good enough. All right, final one here, k of x. Sure, that would be first function times derivative of the second function plus second function times derivative of the first function. Let's go ahead and clean this one up a little bit as well, because x squared times 1 over x is just x plus 2x ln x. And if we wanted to, we could pull an x out of that, leaving us with x times 1 plus 2 ln x. So here we have an AP type problem using the product rule from a table of values. We have differentiable functions f and g, and we have values of f, f prime, g, and g prime for various values of x. So the first one says, let h equal f times g. Find h prime of 3. All right, well, the first thing we should probably do is find h prime of x. And that would be f of x times g prime of x plus g of x times f prime of x using our product rule. So then all we're going to do to find h prime of 3 is everywhere we see an x, put in a 3. Okay, so then h prime of 3 is equal to f of 3, which is 1, g prime of 3, which is negative 4, plus g of 3, which is also negative 4, and f prime of 3, which is 8. And that gives us negative 4 minus 32, or negative 36. For part B, we have root x times f of x. So the derivative of that would be the first function times the derivative of the second function plus the second function times the derivative of the first function. Remember, root x is the same thing as writing x to the 1/2, right? So that'd be 1/2 x to the negative 1/2. Rewriting this, we have root x times f prime of x plus f of x over 2 root x. And just like before, we can take that, and everywhere we see an x, we're trying to find when x is 4. So root 4 is 2. F prime of 4 is negative 1. F of 4 is 10 over 2 root 4, which is 2. So 2 times 2 down there in the bottom. And that gives us negative 2 plus 10 over 4, or negative 2 plus 5 halves. And negative 2 would be negative 4 over 2 plus 5 over 2 would be 1/2. All right, the last one says if f equals g times h, find f prime of 4. So let's start by finding f prime of x. That would be g times h prime plus h times g prime, right? So if I want to find f prime of 4, I'm just going to replace all those x's with 4's. G of 4 is 2. H prime of 4 is 5. H of 4 is negative 1/3. And G prime of 4 is negative 8. So that gives us 10 plus 8/3, which is 30/3 plus 8/3, or 38 over 3. All right, that's it for the product rule. Remember, we're going to use that anytime we have two functions of a variable multiplying each other. Thanks for tuning in. Next time we'll take a look at the quotient rule.